Hi everyone, in this video we'll talk about one of the most important indeterminate form, which is 0 times infinity. We have a lot of indeterminate forms, but this is the first indeterminate form. We cannot apply Hopital rule directly because Hopital rule works when the direct substitution is 0 over 0 or infinity over infinity. So you have to convert this indeterminate form to 0 over 0 or infinity over infinity firstly, then you can apply the Hopital rule. In part A, you have to find limit x e to the power negative x when x goes to positive infinity. When you will do the direct substitution, it will be infinity multiplied by e to the power negative infinity. And e to the power negative infinity equals to 0. So we have infinity times 0, which is the indeterminate form. So you have to convert this limit to functions, two functions, numerator and denominator, and the direct substitution of positive infinity will be 0 over 0 or infinity over infinity. So we can do this by rewrite e to the power negative x as 1 over e to the power x. So our limit is limit x divided by e to the power x when x goes to positive infinity. Now by direct substitution it will be infinity over e to the power infinity, which is equals to infinity. So we can apply or use the Hopital rule to find the limit. So you have to find limit f prime over g prime, which is 1 over derivative of e to the power x is e to the power x when x goes to positive infinity. And this is equals 1 over e to the power infinity, and e to the power infinity equals to infinity, and 1 over infinity equals to 0. For the second part, part B, we have limit x ln x when x goes to 0 from right. By direct substitution for 0, you will get 0 multiplied by ln of 0 from right, and ln 0 from right equals to positive infinity. So we have the indeterminate 0 times infinity. So we cannot apply directly the Hopital rule, and you have to convert this function as a quotient of two functions. So we have limit. We can write x down, but you have to convert it as 1 over x. So it will be ln of x divided by 1 over x when x goes to 0 from right. Now direct substitution for 0, you will get ln of 0 from right, which is positive infinity, divided by 1 over 0 from right, which is also positive infinity. And this is the case we can use Hopital rule to find the limit. So now we can use the Hopital rule. So limit of derivative up, derivative of ln x is 1 over x, divided by the derivative of 1 over x, which is negative 1 over x squared when x goes to 0 from right. So we can write this limit as 1 over x multiplied by the reciprocal of denominator, which is negative x squared over 1. So multiply by negative x squared when x goes to 0 from right equals to limit. Now 1 over x multiplied by negative x squared is negative x when x goes to 0 from right, and this gives us 0. For part C, you have to compute limit x sine pi over x when x goes to positive infinity. Remember that you have to make direct substitution. So by direct substitution, we have x, which is infinity, multiplied by sine pi over infinity. And number divided by infinity equal to 0. So sine of 0 equals to 0. So we have the indeterminate form infinity times 0. We cannot apply Hopital rule directly, so you have to convert the limit as function divided by function. So our limit will be limit sine pi over x divided by pi 1 over x, sorry, when x goes to infinity. Now if you replace infinity up and down, you will get pi over infinity, which is 0, and sine of 0 equal to 0, divided by 1 over infinity, which is also equal to 0. And this is the form that we can use Hopital rule to find the limit. So we can use the Hopital rule. So it will be limit derivative up divided by the derivative down. And derivative up, you have to find the derivative of the inside angle, and the derivative of pi over x is negative pi over x squared multiplied by the derivative of sine, which is cosine the same angle, pi over x, divided by the derivative down, which is negative 1 over x squared when x goes to infinity. Now we can directly cancel x squared with x squared, and negative divided by negative will be positive. So we have limit pi cosine pi x when x goes to positive infinity. Now by replacing infinity in our limit, we get that the limit equals to pi multiplied by cosine pi over infinity, and pi over infinity equal to 0. So we have pi cosine 0, and cosine 0 equals to 1 multiplied by pi equals to pi. In part D, you have to find the limit of tan x ln x when x goes to 0 from right. So by direct substitution, tan of 0 equal to 0 multiplied by ln of 0 from right equals to positive infinity, and 0 times infinity, it is an indeterminate form, so you have to convert it to function divided by function. So we have limit, and you know that tan equals 1 over cotan, so we can rewrite this limit as ln of x divided by cotan x when x goes to 0 from right. Now again, by direct substitution of 0, you will get ln of 0 from right equals to infinity divided by cotan of 0, which is cosine of 0 over sine of 0, which is 1 over 0. That gives us infinity. So we have to use Hopital rule directly because it's the direct substitution is infinity over infinity. Now we have limit of derivative up divided by the derivative down, and derivative up is 1 over x, and derivative down is the derivative of cotan x, which is negative cosecant squared x when x goes to 0 from right. Next, we have two denominators, so you have to combine them, and you will get minus limit 1 over x multiplied by cosecant squared x when x goes to 0 from right. Now all the students know that cosecant x is the reciprocal of sine. So 1 over cosecant is equals to sine. So we can rewrite this limit as sine squared x divided by x when x goes to 0 from right. Now again, if you make direct substitution here, you will get sine square of 0, which is equal to 0 over 0. So we can apply Hospital rule again. So you have to find derivative up and derivative down, and the limit will be equals to minus limit derivative of sine square of x. You have to use the power rule. So we have 2 multiplied by sine x multiplied by the derivative of sine, which is cosine x, divided by 1 when x goes to 0 from right. Now by direct substitution, we have 2 multiplied by sine 0 multiplied by cosine 0, and this gives us 0. In part E, you have to find limit 1 minus tan x multiplied by secant 2x when x goes to pi over 4. Now by direct substitution, you have 1 minus tan of pi over 4, and tan pi over 4 equals to 1. So we have 1 minus 1, 0 multiplied by secant of 2 multiplied by pi over 4. So this is equals 0 multiplied by secant pi over 2. And as you know, secant is 1 over cosine. So we have 0 multiplied by 1 over cosine pi over 2. And cosine pi over 2 equal to 0. 1 over 0 equals to infinity. So we have the case 0 times infinity, which is the indeterminate form. So you have to convert it to 0 over 0 or infinity over infinity. So the limit equals to limit 1 minus tan of x, and as you know, secant is the reciprocal of cosine. So we can rewrite secant 2x as 1 over cosine x. So you have to divide 1 minus tan x by cosine 2x when x goes to pi over 4. And as you know, you have to substitute here, and tan pi over 4 equals to 1, 1 minus 1, 0, divide by 2 times pi over 4 is pi over 2, and cosine pi over 2 equal to 0. We have the form that we can apply the Hospital rule directly. So you have to use Hospital rule, and you have to find limit f prime divided by g prime. So this is equals to limit of the derivative of numerator, which is 0 minus secant squared x, divided by the derivative down, which is negative 2 sine 2x when x goes to pi over 4, and this is equals to limit secant squared x divided by 2 sine 2x when x goes to pi over 4. Now by direct substitution, secant pi over 4 is 1 over cosine pi over 4, and cosine pi over 4 is 1 over square root of 2. So secant of pi over 4 is square root of 2 squared, because we have secant squared, divided by 2 multiplied by sine 2 times pi over 4. 2 times pi over 4 is pi over 2, and sine pi over 2 is equals to 1 times 2 equals to 2. So we have 2 divided by 2, which is equals to 1. And this is the final answer for part E. And that's it. Thank you.